Thank you for joining for this episode of the TechSpective Podcast. My guest for this episode is Kei Karasawa from NTT Research. So, Kei, welcome. If you could share a little bit about yourself, your background, and what you're doing at NTT Research.
Thank you. My name is Kei Karasawa, Vice President of Strategy, NTT Research. And I'm working for NTT Research, and which is conducting fundamental research company to upgrade reality by thinking nonlinearity. What does it mean? So nonlinear thinking is often comes from like academia. So our we are working in academic field basically, such as international conferences. So we talk about cryptography today. And in cryptographic field, for example, there are two top conferences that is crypto in US and Eurocrypt in EU. NTT Research has contributed the most, basically contributed most in the number of academic papers, more than universities such as Stanford or MIT. So that is our current working style.
Okay. So I did attend the NTT Research Upgrade 2021 recently, and at that conference, whatever we want to call it, at that event. You had presented a session on attribute-based encryption. Mm-hmm. So let's just start for those who didn't attend Upgrade and didn't see your session with just a high-level overview of like, well, what is attribute-based encryption?
Okay. Before I explain the attribute-based encryption, so I would like to explain our laboratory itself. So yeah, we have actually 3 laboratories, and one of them is Crypto Information Security Laboratory, which I would like to talk about today. CIS, so in short, CIS Laboratory. CIS Laboratory has 2 teams, that is Cryptography Technology Team and Blockchain Team. The cryptographic team is led by Dr. Brent Waters, an award-winning scientist in computer science. They are basically rethinking cryptography itself, so that that outcomes is really diverse. But to make the long story short, there are 3 major directions. The first, to make the cryptographic algorithm is stronger. So we research the new encryption algorithms like against the quantum computers. The second, to make the system robust. So we research a decentralized system that eliminates the single point of failure. For example, the blockchain is one of the examples, and they don't have any centralized authority. The third direction is to make cryptography itself more functional or flexible. So we research secure computation or secure access control at data layer. So attribute-based encryption is that topic. So that is actually our first step toward the functional cryptography in the actual business field. So I like to talk about the attribute-based encryption. Actually, this technology is invented around 2005, so about 15 or more years ago. Actually, this is a really good timing to make this technology into the business field, because to think about the current digital world, so actually AI and IoT accelerate the digitalization, and the data becomes an asset, as you know. So the data owner would like to control the access rights, because many data-oriented, data-driven architecture is widely used. So, for example, there are many data storage technology or services evolved, like maybe 1990s or 2000, early 2000. The data warehouse is becoming popular. became popular. But then now, the 2010s, the technology changed to data lake. So many data is collected into the data lake, and there are so many unstructured data. But now it goes to Lakehouse, which is actually led by Databricks or other data lake company, is led to that direction, which means that data is collected and well organized so that the third party can reuse the data itself. However, data owner would like to or does not want to reveal the private information in that to the third party. So currently, data owners are masking the sensitive data when it is shared. However, data users, such as data analysts, often want to get more detailed information in the masked data. ABE can provide such an access control to hidden data when data owner approve the access rights to the sensitive data, such as the third party pays money to see it. So ABE can control the access right after we deliver that type of data. So I actually showed the demonstration at our event Upgraded 2021. I demonstrated a personal use cases which might be understandable for everyone. So I talked about data wallet, which is it's a kind of the very small data lake for their users. Actually, data wallet is evolving. We can store credit cards or transfers and so on in the data wallet. We will be able to store the driver's license in this year, I guess, and we'll store the COVID vaccine record. Many people expect it that way in near future. We can use the data wallet at airport or subway or stadium gateway in near future to pass the gateway system by showing our identity. So such as we already got the vaccine passport twice, something like that. However, current data wallet can only control which card should be applied to the system. So it includes sensitive information in the card. So if somebody scan your card, somebody also can get your private information, which for example, which include your date of birth or your home address in your driver's license. So ABE can control the access rights by setting the attribute on each data element in each card. For example, to think about the Stadium Gateway, you need to confirm your name and vaccine record, but current data wallet doesn't control that type of the specific element. But ABE can provide the attribute of name of driver's license or dates of vaccine record. ABE can control the access right by issuing the encryption key to the system. So you can show your encrypted data wallet to the system. The system only can see that specific data element in each card. That is what I said in the event.
Okay. Well, so what I think is interesting about the whole thing, and you've hit on a lot of these things, but I've worked in and around cybersecurity for a long time, and we've always talked about encryption, but the implementations of encryption are over time have not always been the easiest things to deal with, and also can cause pretty big problems in terms of if you lose the key, so key management is a whole separate thing, but then there's just the whole sort of all or nothing aspect to it. Either you have the key and you unlock everything, or you don't have the key and you can't get any of it. Mm-hmm. And what you're describing and what you demonstrated at Upgrade 2021 with attribute-based encryption, I feel like fits much more into the model we have today, both from a security perspective and from like just a technology perspective and the way we do things. So as organizations are, focusing more on, SASE and zero trust and all of these things, attribute-based encryption seems to be something that would play a pretty significant role there in being able to provide that protection at that granular level and not be like a black and white all or nothing.
That's right. Thank you very much. So that is a very important point of attribute-based encryption. So actually, as you said, so current encryption technology is all or nothing. Even though think about the public key encryption, one single public key has a single decryption secret key. So that is all or nothing pairs. However, ABE has a multiple decryption key under the single encryption key. So it means you can put many attributes on the data. For example, if you set the time duration, the available time slot in a single data, so you can control the access right in certain time or location. If you get into a certain place in the certain time, you can only see that data. But after that, you can't see that data by controlling the decryption keys. So from that perspective, you can control very fine grain level. So you don't need to reveal that data after copying the data.
Okay. One of the other things that seems to be sort of hand in hand with attribute-based encryption is the idea of functional encryption. I'm not sure what the relationship is. Like it seems like functional encryption is maybe another way of describing attribute-based encryption. So I guess tell me about functional encryption, or what's the relation, or how does that fit?
That is a quite important topic in the cryptographic academic field. So actually, about 2000 time frame, the pairing function invented in a practical way, which enables identity-based encryption at the time, which means, for example, to think about email system, you need to define the receivers by using email addresses. So we can put the information of the receivers by using email addresses, which means, so if you send the different person, that the data cannot reveal or cannot read by using the decryption key. So we can control the receivers by using the identity, which means email addresses. So in 2000, that technology is invented. And 2005, attribute-based encryption is invented, which can control the access right by using attribute. So which is more flexible, and we can put more flexible policy setting like and/or setting by using attribute strings. So we can control, for example, duration or location. So we can control many flexible access control. But still, we need to reveal data itself in the fine-grained level. So the next step by using pairing function is to show the result of computation. That is a functional encryption. We can put the function on the encrypted data. So we don't need to reveal any information from the encrypted data. That is the point of functional encryption. Actually, we have a similar function named homomorphic encryption, which means once we encrypt the data and send it to the third party can calculate the encrypted data and get it back to the original users. User can decrypt the data and get the result of calculation. That is one of another way to secure computation. However, the third party cannot get anything on that data and nor the result of computation. Functional encryption can enable for the third party to get the information of the result of the computation. That is a huge benefit. For example, so when you think about the encrypted data in your data wallet, so in that case, the system does not need to touch the actual data itself. They send the condition of the batching record, for example. So if you have 2 dates of the batching record, actual batching record, the system can get yes or no answered from the data, encrypted data. So that is one example. Or to think about the VPN communication, you often send the encrypted data in a packet, and it is really hard to find out which packet has malware, which packet has it came from the dark network. Yeah, we can use the IP addresses, but it's really hard to see in the data itself because it's encrypted. But when you use functional encryption on that layer, so we can get the result which packet is which does not have a malware or malicious information in the packet. It requires higher performance, so we cannot provide this technology now, but maybe in a couple of years, we can provide high performance technology in the functional encryption field. So we can provide such kind of really secure computation environment by using functional encryption.
Right. Actually, that touches on the next question I had, or the next thing I wanted to talk about, which was sort of performance and it's like, again, going back in time, it's like the more complex the encryption gets, the more processor intensive it is on either end of that encryption decryption scheme, which might pose a challenge for some weaker systems in general. But now we're talking about a much greater volume of having to because we're encrypting based on attributes instead of just unlocking the whole thing. And so I figured there's a little more back and forth encrypting and decrypting, and how does that what's the impact to the system, or will an average system today handle that, or do you need to have a higher end system?
Okay. So actually, in the past, AD does not work practically because it takes a lot of time. But currently, it's more practical because the CPU getting higher performance and a couple of the accelerator works very well. For example, so we have performance test about the huge amount of data, like 400 megabyte data. And we are using i9 processor to decrypt it. So it actually completed within 10 milliseconds. So it is quite good performance to put it into the data lake applications. So, but to think about AES or higher performance algorithm, so it is already implemented in the hardware level. So it takes about a couple of the microseconds to decrypt it. So it's about 100 times slower than the AES or such kind of the hardware implemented technologies. However, it still has a good performance. So we can put it in a POC field, and we can evaluate how it works with the customers. So this is the stage of the toward the business development.
Okay. What does for a few years now, we've in cybersecurity circles been or IT circles really, there's talk of quantum computing, and then there's always talk about, well, as soon as we have quantum computing, basically all of our encryption is broken. There's nothing we can do about that, and we basically in order to fight quantum decryption, you would have to come up with some quantum encryption. But our existing encryption algorithms will be essentially rendered useless as far as I understand it.
Yes.
So I don't know where we're at, in terms of, is that a technology we would expect in the mainstream in 5 years, 10 years, 20 years? Will it, is it purely theoretical and it won't really be a mainstream technology? But my question would be, sort of what timeline do you kind of anticipate for that, and what does that do to ABE?
Okay. Yeah, actually, as you know, NIST is now standardizing the post-quantum encryption technologies, and it will be appeared in a couple of years. So it will be, it is a little bit different from practical applications, is ready for the post-quantum encryption. However, we actually analyze a couple of the algorithms, and it will performs very well, basically. So if you put the very simple use cases like AE types of very simple use cases like RSA type public key encryption by using post-quantum encryption algorithms, it works well. About less than 1 second, we can get the results. That type of the level of the performance we can get now. But so less than 1 second is not so good enough. So we need to get 10 times or 100 times performance toward that. But I expected the simple use cases, just encrypted the whole data, is applicable in a couple of years, just after the standardization completed. But to think about ABE, so actually we can combine that technology into our system. We are now based on the pairing functions, but we can put that type of so we call the lattice-based technology against the quantum computers. That is the mainstream of the post-quantum encryption technologies, and we can combine the lattice-based algorithm into ABE scheme or functional encryption scheme. So we can test it now, but still it takes a lot of time, and then very limited amount of data can be handled. So it is now under testing or under developing, and we need to develop more high performance coding method to make the applicable software into the business field. It takes about a couple of years, but we can work with parallelly. So we will find the post-quantum application in 3 or 4 years. I expect it.
Okay. I'm going to jump back a little bit because it's kind of shifting gears from talking about this quantum computing thing that doesn't even really exist yet. But one of the things that I had wanted to hit on, which is much more relevant now today, is the just sort of exponential explosion of IoT devices, and that has dramatically increased the attack surface. Many of them are weak from a security perspective. I think and I've written about this and I've had this conversation with others, but it's like I think people don't even realize actually how many IoT devices there actually are. I mean, like average consumers, you say IoT and they think Nest cameras and Ring doorbells, and it's like, okay, well, yes, but there's a billion other things out there that that aren't necessarily consumer facing, that have access to manufacturing sites and water treatment facilities and whatever else. It's everywhere. How to I know it's been touched on in some of the stuff that I've seen from you and from NTT Research on this, but I wanted to kind of share with the audience, like, how does ABE help us kind of address that issue of the insecurity of IoT?
Okay, thanks. So actually, we expected zettabyte of data is generating in near future, and we need to manage that type of data. But to think about raw data, it has a lot of noises or useless information. So we need to arrange the data into more reusable way. So, for example, to think about the surveillance camera information, and at night there are no information there, no cars, no people. That type of the information does not. I think it's not reusable. So we need to put the information by using AI technology, for example, to use a facial recognition or maybe sound recognition for the car accident or something. So to make that information as a metadata of the information, we can use that data to the third party for third party. It means so metadata controlling is very important to reuse the data. Actually, data lake company or many data integration company is focusing on how to control the metadata. And metadata itself is attribute of the data. So it means we can encrypt the data by using attribute-based encryption. So we can, if you think it is sensitive information, for example, to accident of the intersection or the people face with people name, that type of information is quite sensitive. So we can encrypt the data by using metadata like accident type or people name of the data. And you can put the attributes. So the name itself is the attribute. So name and this is the name is the attribute of the data. And you can create the decryption key by using people name. And also this data has a name. So you can provide the key for the police for this is accident and this is the people face. So police can get the information by using decryption. So that type of access control is quite useful for the data lake, like a smart city. So the smart city collects many information from surveillance camera, but this is a really difficult problem to share it to the with private information. So we are now deleting that private information, but it has a very useful information inside. So we would like to create a metadata and put the encryption technology on it by using ABE technology.
Okay. If I'm a business, an enterprise, whatever, and I'm and I find this whole conversation interesting, and I want to look into this. Is this a tool? Is this a product that I would buy from NTT Research, or is NTT actually two-part question. Number one, can I just buy it from NTT Research? But number two, is NTT Research in any way partnering or working with other vendors where if I buy their thing, it just has this built in?
Okay. Yeah, actually, we are now working. Actually, I am working that type of the formation to deliver our technology into the customer. So actually, NTT Research itself is a research institute. So we are focusing on to generate the academic papers, technology itself. But we also have a small amount of software to evaluate our technology itself. So we brush up that core software with NTT operation company like NTT Data Services or NTT Limited. So we have a couple of the technology operation company. So that company will make this core software into the services. For example, to think about the NTT R&D Japanese teams, we have a couple of the subsidiary company like NTT Technocross or NTT Advanced Technology, which is 100% subsidiary company, NTT Holding, and that company is only focusing on to deliver our R&D technology into the market. So we are collaborating with NTT Technocross team and also the NTT global operation companies to make that type of software into the market. For example, we are now working with Australian government. NTT Holding has a MOU with New South Wales State in Australia, and they will provide a smart city services to the citizens. And NTT will provide or support that type of activity by providing our cutting-edge technology. ABE is one of the candidates to make the smarter city from the cutting-edge technology perspective.
Okay. Yeah, I mean, like I said, I find it all interesting, and especially from this perspective of, like I said, I've known for years, I've said for years that people need to be encrypting, got to encrypt all the things, but the ease of that and the technology behind that haven't always been there. But now, like I said, as we kind of move to 0 day, and even, I mean, I would say even with the recent move by Microsoft to try and get rid of passwords and like all of these things, I do feel like they move things forward in terms of both user experience and security. But you need to have pieces underneath, and on the back end like this that allow you to do that.
Yes, that is quite important part. Yeah, actually, current encryption technology, as you said, all or nothing. So if you get the password, you maybe somebody get all information under your password. But when you use ABE technologies, we can control the access right by deliver the different decryption key for each users. So each user doesn't. So data owner doesn't need to care about the access right for the certain person. So you don't need to care about whole information to reveal the single place. So that type of the access control is quite important for the future data lake technologies.
Real quick, so I was kind of winding down, but it just occurred to me. How would ABE help in a ransomware situation? So the exploit is in the network, and they initiate it, and it goes to start encrypting all of your data. Would because when you were just talking, it reminded me of it. It's like, well, yeah, once you kind of get in the door with our standard encryption, once you've gotten inside, you kind of have access to everything. And then I was thinking, okay, well, wait, what if the ransomware attacker gets inside, but there's ABE and they don't have the key to everything? Right.
So to think about the ransomware from single person. So maybe the bad guy send the email to the one guy and to get the password from that guy, and they get into the system and decrypt the whole thing. So that is a type of the ransomware attacking. But to think about the ABE type, the encryption, so that the single person has only access right to the single certain place. So actually, the bad guy maybe encrypted the data which the guy can access to. So it might be affect a certain area. So it's hard to protect that by using encryption technology. But the access-like control is quite useful to all or nothing type of the technologies.
Well, it sounds like it would be a almost another way, or a different way of sort of implementing or enforcing least privilege access. It come back to the same reason, why we always said, well, don't give someone admin rights on their computer. If they, if you only have local access, then that's all the attacker can get to. Mm-hmm. And so in a similar way, it's like, well, we've, with ABE, you're at least going to limit it to, you're limiting the blast radius. So yes, I can still encrypt, but at least I can only encrypt the stuff that Kei can get to. Mm-hmm. I mean that's something. It's better than not having that.
Right. Yeah, it's really hard to stop everything, but we can control the amount, the levels of the security. So yeah.
Right. Okay. That was pretty much all the questions I had. But I always like to kind of put it out there as I'm winding down and just say, is there anything else you want to say on the subject? Is there a question I didn't ask that you want to make sure we touch on it? And I'll just reiterate or not reiterate, but stress that when the podcast is published, I will also include the link to the demo from Upgrade 2021, and I will and include a link to some of the assets on the NTT Research website, so that the audience can click on those and get some more information as well. But yeah, is there any parting thoughts you have?
Thank you very much. So actually, we just completed our demo system, and I would like to show this demo system as much as possible. So if you have any interesting or to collaborate with us, please let us know. I would like to show this demonstration in person, and I would like to upgrade the system to your specific environment. I would like to happy to talk about what kind of value we can provide to the actual data lake situation. So I'm really interested to talk to you guys. Thanks.
Awesome. Well, thank you very much for taking the time and joining me, and thank you for all of the work you're doing to try and help us use our computers more safely.
Thanks a lot. Yeah, I'm very happy to talk to you. Thanks.
I appreciate you investing your time to listen to the podcast, but I also invite you to engage on social media. Please go like our Facebook page and follow @TechSpective on Twitter and Instagram. You can feel free to let me know what you like, let me know what you don't like, let me know if you love it, let me know if it sucks, and let me know what products you'd like to see reviewed or what questions you'd like to see answered in future posts.